Hello and welcome to Data School. This video tutorial is going to cover many of the new features in dplyr versions 0.3 and 0.4, as well as some other functionality that I didn't cover in my previous dplyr tutorial. If you haven't already watched my previous tutorial, I strongly recommend you watch that first. That video covered the basic functionality of the package using version 0.2, and I won't be repeating that material here. I'm going to be walking through an R Markdown document that I created here in RStudio. If you want to follow along, this code is available on GitHub, and there's also a rendered version of this document on RPubs that you could use as a quick reference guide. You can find links to both of these below the video. Alternatively, you can just type the commands as you go. One other note before we get started: if you have any questions about anything in this video, please let me know in the comments below, and I'd be happy to answer them. And with that, let's get started. So the first thing you should know is that even though my last tutorial used data from the hflights package, Hadley Wickham, the chief author of the dplyr package, has rewritten all the dplyr vignettes to use the nycflights 13 package instead. And so for the sake of consistency, I'm going to use nycflights 13 also. So if you just finished my previous tutorial, you'll want to run this line of code, remove flights, to make sure that you get rid of the flights object from your environment. Alright, so let's go ahead and load up the dplyr package, and then we're also going to load the nycflights 13 dataset. If you don't have it, you'll just want to install that now. And I'll print the flights dataset from nycflights 13. You can see that there is one row of data, one observation, for each flight, and there were 336,000 flights. These are just flights from the New York City area airports. So let's jump right in to our first couple commands. We've of course seen the select command before, and this is used to pick columns. So in this case, I am just picking the columns carrier and flight. Throughout this tutorial, I'm going to be using this pipe operator, which I'm going to call then. So in any case, besides using select just to pick columns, you can also use select to hide columns. So let's say that you want to select all columns except for the month and day columns. Well, I can just do that like this. And as you can see, I'm now showing 14 columns instead of 16. Alright, so you might remember that you can use select to select a range of columns using this colon operator. And in this case, I'm going to actually use the minus sign to hide a range of columns. So in other words, this hides all columns between and including departure time through arrival delay. We can also use the minus sign to hide columns matching a name. So let's pretend that all of the columns whose names have time in it are not of interest to me. Well, I can say select minus contains time, and it will hide those columns. So for example, the airtime column is no longer shown. Now here's a piece of new functionality. Let's say that I have a character vector, which I'll call calls, and it contains the names of some columns that I want to show. Well, there's now a command called oneOf, and I can pass it to select. So I say select oneOf calls, and it will only select those columns. Now you might not know that select can also be used to rename columns. And let's do that here. and we see that I have selected the tail num column, and I've renamed it as tail. Note that when I do this, all columns that I don't mention, they're dropped. Now this probably isn't that useful to you, but there's a new function called rename that does the exact same thing, except all columns not mentioned are kept, which is more likely what you want to do. So you can see that we now have the tail num column, and it's been renamed to tail, but all the other columns that I didn't mention are still here. All right, let's move along to some functions for filtering. So you might remember that the filter command, which filters rows or observations, supports the use of multiple conditions. So in this case, I'm filtering to only show rows where the departure time is greater than or equal to 600 and the departure time is less than or equal to 605. In other words, this is flights that departed between 6 o'clock and 6:05 in the morning inclusive. Note that I use the comma to separate these conditions, but I can also use the ampersand. If you're doing this particular operation, where you're selecting these endpoints, you can actually use a new command called between. So this is a more concise alternative for determining if numeric values fall in a range. And so if I say between dep time 600, 605, it's the same as this command. And once again, I'm filtering, and again you can see that all of these departure times are between 6 o'clock and 6:05 a.m. As a side note on filtering, I found that the is.na can actually be quite useful within filtering. So in this case, I'm filtering flights to only show observations in which dep time is not an NA value. So you can see that now we only have about 328,000 observations out of those 336,000 observations. Moving on to another new verb called slice. Slice is used to filter rows by position. So for example, here I'm going to show only rows in positions 1000 through 1005. Now, you might wonder how that might be useful. You've already got the head command to look at rows at the top and the tail command to look at rows at the bottom. Well, it's possible you might want to just slice some rows out of the middle and take a look at those, and this is an easy way to do that. But this probably isn't the most compelling use case for slice. What I found is that slice is actually most useful for filtering rows within groups. So in this case, I'm going to group by month and day, and then I'm going to slice out the first 3 rows within each group. So as you can see, I've got 3 rows for January 1st, 3 rows for January 2nd, 3 rows for January 3rd, and so on. And these are just the first 3 rows that dplyr encountered within those groups. Now, perhaps I don't want to look at just the first 3 rows. Instead, I want to sample 3 random rows from each group. Well, there's a handy command called sample n, and I'm going to just pass it a 3, and that just means within each group, I want to see 3 random rows. So maybe I don't want to look at the first 3 rows or a random selection of 3 rows. Maybe within each group, I want to look at the 3 rows that have the top departure delay or some other variable. Well, I can do that with this top n function. And what I do is I pass it the number of n, so the number of rows I want, and then I pass it the variable on which those rows should be chosen. So let's run this. And what we see is that, again, I have I have 3 rows for each day of the year. And then within those, the particular 3 rows that were chosen were the ones with really high departure delays. So as you can see earlier, I was just getting arbitrary rows, and here I'm actually getting one specifically with high departure delays. Now, you might note that they're not actually sorted within each group, which to me is probably what you'd want to do if you were doing this particular operation. So just note that you can throw on an arrange function at the end, and if I say arrange in descending order by departure delay, then I get what I actually want, which is I'm getting 3 rows from each group with the top departure delay, and then I'm sorting in descending order by that departure delay. Moving along, let's say you wanted to identify unique rows. So, for example, I want to select origin and destination, and I want to see all unique origin-destination pairs. There's a unique function from base R, so let's run that. And we'll see that there were 224 unique pairs of origins and destinations in this data set. Now, dplyr actually has an alternative command called distinct. And you'll see that the results are the same, but it's a more efficient command, so this is what dplyr recommends you use instead of unique. And as a side note, and this is something I just learned, is that when chaining, you actually don't even have to include the parentheses if there are no arguments. So, for example, with distinct, there are no arguments I'm including, and thus I can actually just run it without the parentheses. It looks kind of funny to me, having, being used to seeing a lot of parentheses in R, and I don't know if this is officially endorsed and whether this behavior will stick around forever, but at least for now it works, and it certainly makes your code a little bit shorter, saves you some typing. So let's move on to adding new variables. So we've got mutate, which has been around from the beginning of dplyr. So mutate is how you create a new variable. And let's say I want to create a new variable called speed and have it be a function of distance and air time. So this is speed in miles per hour. I run mutate, and although we can't see it here, we've got a new variable speed. And you'll notice that mutate kept all the existing variables. Now, there might be times when you only want to keep the variables you just created. And that's the purpose of the new verb transmute. So the syntax is the same, and when you run it, you see that the only variable that was kept is that new variable. Now let's move just briefly to a different data set built into R called mtcars, very famous R data set. And we're just taking a look at the head, the first 6 rows. And you can see that mtcars uses row names to store the model of the car. Now in kind of tidy data principles, this is not recommended. It's recommended that you, instead of using row names, you make this an explicit variable in your data frame. And as such, there's this new verb called add row names. So what it does is it takes any row names in a data frame and it turns them into an explicit variable with the specified name. So let's do that, and you'll see that I've now created a new variable called model that just took the row names from mtcars. Now, as a side note, anytime you are creating a local data frame, and you create a local data frame using this tbl_df command, also known as tibblediff. If you like local data frames, they used to print row names under some circumstances and not in other circumstances. Well, dplyr no longer prints row names ever, so you should not plan to see them anytime you're using local data frames. Moving on to some grouping and counting operations. And the first is just a review of summarise. So let's say I want to group by month and then summarise count equals n. So what is this exactly? It means for each month I want to calculate the number of rows, and one row represents a flight, and store that in a variable called CNT, or count. So let's run this, and this is telling us that in month 1 there were 27,004 rows, which represents the number of flights. In February there's this number, and so on. So this is nothing new. I wanted to compare that syntax with tally and count. So tally is a way that you can do this slightly more concisely. So tally just replaces this summarise command, and when I say tally, it does the same exact thing, except it automatically assigns n as the column name, so I couldn't define it as CNT, it's just automatically n, but it saves me some typing, and it's a bit cleaner to read. Now a new way to do this is to use this count function, and this makes it even more concise because it automatically does the grouping for you. So this line of code, count month, does exactly the same thing as above, which does the same thing as here. Now I'm going to show a couple more examples of comparing summarise versus tally versus count. So here's, let's say that I wanted to sort this data in descending order. I of course use an arrange command, so arrange descending count. So let's run this, and now we can see that July is the month with the most flights and February is the month with the least flights. I can also do the same thing using tally, using this optional parameter called sort, and I'll say sort equals true, and you see that tally does the same thing. And then count also has that same parameter, sort equals true, and again it does the same thing. So that's another comparison of summarise, tally, and count. Now note that when you're summarizing, you can do a lot more than just counting the rows in each group. You can, for instance, sum over a specific variable. So in this case, for each month, I'm going to summarize, and I'll say dist equals sum of distance, which means that I want to sum up the distance values for each row and store it in a variable called dist. So let's run this. And we'll see that, for example, in January, this was the number of miles that was flown, and this was the number flown in February, and so on. Now, again, with tally and count, you can do the same thing. So with tally, you have this optional parameter called WT, which I just call weight. So this weight parameter specifies the same thing here, and it will do the sum of that particular column instead of just counting, and you can see I get the same results. And then count again has the same weight parameter. Now coming back to counting, so remember this command here. So for each month I want to tally. Alright. Now let's say that I want to quickly get these numbers into a vector for some reason. Well, that's the function of this group size function. So let's run this, and you can see that I get the same exact results as here, except it's now just been turned into a integer vector. Okay. Now for something even simpler, maybe all you care about calculating is the number of groups. We know in this case that the number of groups will be 12 because there are 12 months, but in your case you might have data in which all you want to calculate is the number of groups, and that's what ngroups does, so it just tells me I have 12 groups. Next I want to just show a little bit of behavior that is a bit confusing to me, and in case it's confusing to you, I want to show you kind of a workaround. So let's pretend I'm grouping by two variables, in this case month and day, and then I'm doing a summarize, doing a count, and then I doing an arrange, okay? And one thing I'm going to throw on at the end here is this print function, and say n equals 40. That allows me to print 40 rows. So let's go ahead and run this, and let's take a look at what we've got. So I grouped by month and day, so there are of course 365 groups. Now there's something that's a little funny to me. So I see that it does look like it's in descending order, but notice that all of these are from January. So there were 943 flights in January 2nd, and that was the greatest for January. But if I want to see February, it has to go all the way down here. So in other words, it's sorting only within month, whereas what I had really wanted is sorting across all groups. So I wanted to know, for instance, the top 10 days throughout the year in terms of number of flights, not just the top ones from within each month. Now, why exactly is this occurring? Well, I did some research, and it turns out that every time summarise is called, that removes a grouping level. So even though I group by month and day here, as soon as I called summarise, it actually drops a grouping level. So now it's only grouping by month, so when I arrange, it's arranging with that in mind. Now there is a workaround, and it turns out that there's this command called ungroup. So it essentially removes any groups that have been defined, and I just throw that in after the summary, but before the arrange. And if I do that, and this time I'm just showing 10 rows, you can see that it's sorting across all months and days. So I can see that the day of the year in 2013 in the New York airports that had the most flights was November 27th, followed by July 11th, etc. So ungroup can come in handy if you're experiencing behavior like this and it's not what you want. Moving along, let's talk about creating data frames using data_frame. Now this is not data.frame, this is data_frame, which is a new thing in dplyr. So data_frame is a better way than data.frame for creating data frames. So what are some benefits of data_frame? Well, you can use previously defined columns to compute new columns, and we'll see an example below. It never coerces column types. It never munges column names. Never adds row names. It only recycles length 1 input, which is probably what you want. And it only returns a local data frame, which is what dplyr encourages. So let's do a quick example of data_frame. And what I'm doing is I'm creating a data frame with 4 columns, and I'm sending it to glimpse, which is kind of dplyr's version of str, str. So what do we see? We see that A has been created 1 to 6. B has been created as A times 2, which does work. When I created C as string, you'll see it stays a character instead of being automatically converted to a factor. And when I created D plus E as my 4th column name, it leaves that as is. It doesn't change it. And you can't tell from this glimpse, but this is actually a local data frame. So let's compare this to data.frame, your standard way for creating data frames in R. I didn't bother trying to define b equals a times 2 here because that would fail with data.frame since a doesn't yet exist at this point. So you'll notice that when I do c equals string, it gets turned into a factor. When I say d plus e as the column name, it gets turned into d dot e. And for what it's worth, this is not a local data frame. All right, let's move on to joins, or merges as they're sometimes called. And there's a number of different joins. We've got 4 what are called mutating joins, and then 2 filtering joins. If you already know joins, this might be pretty elementary for you, but I'm going to presume that you're not familiar with joins. So let's create 2 simple data frames, which I'll call A and B, and take a look at them. And in case you're wondering, anytime you wrap an assignment statement in parentheses, it automatically prints it out without you having to explicitly tell it to print. So what do we have? Well, we have data frame A, which has color, green, yellow, red, and num, 1, 2, 3. And then data frame B, which has color, green, yellow, pink, and size, SML, for small, medium, and large. Okay? So let's start with what's probably the simplest to understand join, the inner join. So that type of join only includes observations found in both A and B, and dplyr will automatically join on variables that appear in both tables. So the only common variable is color, so it joins on color. So what this inner join results in is we see green and yellow because those appeared in both A and B, and then I get the num column for those observations from A, and the size column for those observations from B. Okay. Next, we'll do a full join, sometimes known as a full outer join. And what a full join does is include observations found in either A or B. So this time, we'll see green, yellow, and then red, which came from A, and pink, which came from B. We'll see both num and size. But because red did not have a size, there is no red in B, size gets an NA value. And because pink was not in A, it has no num value, so that gets marked as NA. Okay, so that's our full join. Our left join is for including observations found in A. So anything found in A will be shown. And so, of course, we see green, yellow, and red. We see num 1, 2, and 3. So far, this is just what we already had in A. But in addition, we also have this size column. So size, small, medium, and then NA. So it's basically these 3 rows, but only those 3 rows because left joins only include the observations found in A. Okay. We've also got a right join. So when I do right join A, B, it only includes the observations found in B. So we've got green, yellow, and pink, and then the num, and then the size. So this is just like rows 1, 2, and 4 from our full join. Okay. Now, a lot of people aren't used to right joins; they just use left joins. And of course, you could just do a left join of BA instead of a right join AB, and they are indeed identical, except for the column ordering. So let's do a left join of B and A, and you'll see that it just swaps the column ordering. So it just all depends upon what you want in terms of your resulting column ordering. Finally, let's do our kind of filtering joins. So the first is called a semi-join. So when I do semi-join A, B, that filters A to only show observations that match B. So I don't gain any new columns. All I did was I lost the red observation from A because red was not found in B. Now the opposite of that is an anti-join. So this filters A to only show observations that don't match B. So you can see that between the semi-join and the anti-join, we have all of A. Okay? Now, of course, matching variables don't always have identical names in different tables. So I'm just going to rename the color column in B to be col instead. So how do I do my join in that case? Well, I actually just need to add on this argument by equals, and I pass it a character vector that says color equals col, and then if there were multiple, I could just say comma and then indicate others, but by telling the inner join that color in A equals col in B, it successfully completes the join even though they had different column names. And finally, let's wrap up with some tips for viewing more output. So let's say you want to print more than just the default of 10 rows. Let's say you want to print 15. Well, you can use this handy little print function and say print n equals 15. Note that you do have to say n equals. You can't just put the 15 there. And of course, I see 15 rows. Now, let's say your data frame has a couple hundred rows and you want to see all of them. You don't want to be constrained to see only 10, but you don't know exactly how many. Well, you can just say print n equals inf, which means infinity or infinite. Now, I'm not going to run this in this case because we've got 300,000 rows, but you may find this to be handy for smaller data sets. For seeing all columns, this is the trick I use most often. If I say print width equals inf, I get to see all the columns. So I'm still limited to the 10 rows, but dplyr is indeed showing me all of the columns. Now, a different way to accomplish kind of the same objective is to use this view function, which does not come from dplyr, I don't believe. It's a capital V in view, if you couldn't tell. So let's run this, and it opens up this data viewer that you might already be familiar with. And as you can see, we can see 1,000 rows, so all the way down to row 1,000, and we can see all the columns. I'm sure there's a limit as to how many columns it will display, but I don't know what that limit is. So I'm going to go ahead and close that. So that's another way to view more data without printing it out in your console here. Let's say I want to set some options. So it turns out maybe I like dplyr to print 6 rows by default rather than 10. Well, I can change dplyr.printmin to 6. And maybe I always want to see all columns. I can put dplyr.width equals infinite. So let's run that. And now, if we look at flights, we'll see 6 rows and all of the columns without having to use this, this print command. Now, if I want to reset this, I can set dplyr width back to null and dplyr.printmin back to 10. And that will reset my options to the usual options. Alternatively, if you just close R, it will reset your options. And I'm sure there's a way to set these options to be permanent upon startup if you like. So that's it for the code. I'm just going to go through a few resources now. The release announcements on the RStudio blog for version 0.3 back in October and version 0.4 in January of 2015. I linked to those here. They're a nice quick read. The dplyr reference manual in vignettes on CRAN, those are certainly worthwhile. There's a lot of vignettes. They're always being updated, and they're quite thorough in covering certain aspects of dplyr. One particular vignette that might be of interest to you if you want to learn more about joins is this two-table vignette. Specifically, it also includes set operations, which I did not cover during this tutorial. Highly recommended is RStudio's data wrangling cheat sheet, which is a 2-page, very well-designed visual cheat sheet for both dplyr and tidyr for tidying data. And finally, we've got the dplyr GitHub repo if you want to keep up with development, or the list of releases, and you can read the very detailed release announcements, which is a lot of how I prepare for these video tutorials, is reading those in depth. So, thank you so much for watching. If you have any comments or questions, please let me know in the comments section below. And if you enjoyed this video, I'd love to have you as a YouTube subscriber so that I can let you know when future videos come out. So please do click the subscribe button. As well, I have a blog and an email newsletter in which I cover a much wider range of topics, including R, Python, Git, machine learning, and data science in general. So please check those out. And again, thank you so much for watching.